1 second, a call is coming. I
Oh,
just
okay.
receive it.
Yes, sir. Yes, sir. I think you're mute. Right.
Yeah. So basically, it was minus 16x x plus 1 whole square, x minus 3 by 2 cube. So this is x minus 3 by 2 cube. So when you will plot the zeros, so 1 0 is minus 1 as we plotted, another is 3 by 2. Where else this polynomial will become 0? Won't it become 0 at 0 also? Because this is also a factor, no?
Yeah.
This is a factor. This is a factor. X is not a constant, it is a factor. So it is actually x minus 0 to the power 1. So when you now plot it, what will happen? You start from the rightmost region, right? So when you start from the rightmost region, what will happen? That it will be something like this, maybe that it is, we don't know it is convex or concave. So we can start like this, that it is like this from below the x-axis because it is minus 16. Then it will cross and it will be convex. And then at 0, it will cross simply with the same curve. And then at minus 1, it will. So this would be something like this.
Okay.
So is this clear to you, Sathya?
Yes, sir.
So first we see here that it is 3 by 2 and it is concave here. Then from concave, it becomes convex. So this you have to take care of because the power is 3 now. So if
Yeah.
it goes like this, then it goes like this, curve like this. And at 0, since the power is 1, it will simply cross, keeping the convexity as it is. It will not change. And then at minus 1, it will bounce back.
Okay.
So now you can ask you about. You can share if you want to share. I will stop sharing. Should I stop sharing?
Just a minute. So I'll draw it. So in every case, should that be a 0 or like only in this case there's a 0?
It is x now. So x is x minus 0.
Okay.
If there is x, that means it is x minus 0. If
Yeah.
nothing is subtracted, then it is 0. If it is only minus 16, no x is there, then it is fine, which you are trying to do with a small convexity concavity issue.
Okay.
Should I stop sharing?
Yeah, yes, sir. I'll screen share. I have the
Okay, I'm done.
so the assignment. So
Okay, fine.
this one I got the graph.
This graph you draw.
Yeah, I used the online grapher. They've given me a site to use. So
Okay. So you took 0, you took 3, and from 3 it is positive, then it comes back at 0, then it comes at -1, then it comes back at -2. Fine. Graph is all right.
okay. And these are the questions, but I don't know if they're right. These
What is the degree of the polynomial function? So it is fourth degree, correct. What is the sign of the leading coefficient? It is positive. What is the end behavior of fx? So end behavior of fx means it is concave and it is positive. This is what they mean, I think. Is there any option given?
no, sir, no options.
End behavior, something like that was not in the presentation.
Yeah,
So what do you mean? What do they mean by end behavior? Maybe in the video they have shown. End behavior may mean two things, either concavity, convexity. So it is concave, and another thing is positive. So I think they are not talking about concavity, convexity. That is way too advanced. It is not needed. So you'll just say positive.
okay. Then what is x and y
What
intercepts?
are the x-intercepts? Where it is intersecting on x-axis. So it is intersecting at zeros, 0, 3, -2, -1. Whatever critical points you have plotted, zeros you have plotted, that
So
is
it's minus
3
3, 0, and -2.
and -1 also.
Oh yeah, yes, -1.
These are the x-intercepts.
Okay,
And y-intercept, where it is intersecting the y-axis. So it is intersecting the y-axis only at 0,
okay.
no other point.
So for this, the equation I got is x to the power 4 minus 7x squared minus 6x. Should I show?
Uh, are they asking that?
No, they haven't. But then I got
Okay,
that.
so I'll have to just check by calculating, but still, if you have done the calculation correct, you will get it. That is
Okay.
just multiplying the terms. First,
Yeah,
you will multiply two terms, then you will
and then the other
multiply
one.
that two term will be the third term,
Yes,
and then
sir.
finally you will multiply x with each of them.
Okay. Yeah, so and then I didn't understand what is the domain and the range.
Okay, domain and range. Domain is the value of x. So here the value of x will be whole real number. That is the input. You can take x any value, right?
Okay.
And value of the y, that is the range, is actually according to the graph. Can you slightly minimize it?
The graph?
Slightly. Yeah, so this is the lowest value, as you can see here, is -24,
Yes, sir.
and the highest value is infinity, that is no limit.
Okay.
So you will say -24 comma infinity. Let me write it for you. Should I share the screen?
Yeah, yes, sir. Yes, sir.
So the domain in that graph is actually coming out to be real number, which you can also say that -infinity to +infinity. All the values of x will be taken as the domain. That is input, that is x, and output, that is y, is the range. So range is -24, which was its lowest value, to infinity. So -24 is included. So we'll put a square bracket. This is called a square bracket. There are two type of brackets, a square bracket like this and open bracket like this, where it is not included.
Okay.
So you can write this. If other questions also of domain range will come, you will just do the same thing. You will see the input and output, and that will be the domain and range.
Okay. So, and then that was a second question as well.
Okay. So let me stop sharing this. Yeah, you can share that.
This is the question.
This is done now. This we have done.
Oh, I'm sorry. This one. This is the question, sir.
Oh, okay. So this question, let me see. X plus 1 whole square, 3 minus x. So you have to take minus common and then x minus 3. Then 3 and minus 1 are 2 points. I will form from negative side, and 3, it will not change its nature. And yeah, fine, perfect. You have drawn it perfect. Degree is 3, fine. What is the sign of the leading? So it is negative. Fine. It will be negative now because 3 minus x will become x minus 3 and minus will come outside.
Yeah. So the final equation I got is negative to the power 3 plus x to the power 2 plus 5x plus 3.
Okay, that is fine. That is the calculation part. Yeah, fine.
Yeah.
What
So,
is the end?
end behavior for this will be negative or positive?
Negative. End it is negative.
So, but isn't it going both down and upwards?
End means right side. I think they should mean end means right side.
Okay.
We go from minus infinity to plus infinity. We move from left to right.
Okay. So this one is positive. Sorry, negative.
This is negative.
And the x-intercepts are -3 and
Not minus 3. It
plus
will be
3,
plus 3. Yeah,
+3 and -1.
yeah, minus 1.
Okay. And the y-intercept is +3, only
Plus,
+3.
correct. Only plus 3.
Okay. And the domain and range for this is R again, the domain,
Yeah,
and a range, what will it be, circus?
it will be R
Oh,
because it has no lowermost point or uppermost point. It is
okay,
from minus infinity to plus infinity.
okay. So both are R.
Yeah.
Yeah, that's it. So I think it's the assignment. That's it.
So we can move on to the next topic today.
Yes. Sir.
Satya, can you excuse me only for 4 minutes? Actually, I've not done my lunch and I got it just now. So can I
Okay,
finish it? You can just go through those slides for a moment while you
okay.
meanwhile open it. I will do it and I'll just I'm here only.
Yeah, okay,
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 I'm
sir.
just only two,
Okay,
4 minutes I need from you.
sure, sir.
Yes, Satya. Now we can start.
Yes, sir. So this is the starting.
Wasn't it odd and even or something like that? Odd
No, no, sir,
function.
that is over. I think we finished that. I think that's the last one. This one.
Yeah, yeah.
So we finished that, I think.
But odd even was remaining there, no? After this. Yeah.
This
Yeah.
one. Okay,
This
yeah,
we didn't do. That we
maybe.
said now we will do in the next class.
Yeah,
Actually, there was a time for another class and there is same link for another class. So
okay.
we had to exit at that time. So can you just zoom these
Yes, I
slides?
just want to open the. Yeah, yes, sir.
Okay, it is the odd function, fine, symmetrical about the origin, even function symmetrical about the height. Take next slide. Can you spot the odd function? Okay, and this is the graph of this. Okay, next.
I think that's it, sir.
That's it. Okay, fine. So it is a very small. So let us finish this quickly. So here, what we have is two type of functions. It may be possible it is none of them. So one is odd function, another is even function. So what are odd functions and what are even function? Basically, when we take a function which is f of x, y is equal to f of x, and in place of x, we insert minus x as the input, and we find the value of f of minus x, and you get the same output as f of x with a negative sign. So this type of example is, suppose fx is equal to x cube is a function. Now you insert minus x here, so it will be minus x cube. So minus x cube minus will come outside. So it will be minus x cube, which will be minus f of x, because f of x was x cube. So f of minus x is becoming minus f of x. So graphically, what is happening over here, if you see the graphical portion of this, that if you are taking, suppose 2, so 2 cube is equal to 8, and minus 2 cube is equal to minus 8. So as you change the sign of the input, you get the opposite sign of the output with the same magnitude. You are getting 8 here, and you are getting minus 8 here. And graph of x cube will be something like this. This is little bit correct it. This is a curve. This is plus 2. This is minus 2. And the curve is like this. So here you are getting 8, and here at minus 2 you are getting minus 8. So 2 cube is 8, minus 2 cube is minus 8. So this is a graph which is a odd function, and it is symmetrical about origin. If I draw it more clearly here, it would be something like this, that it is a graph which is like this. So it is symmetrical about origin.
Okay.
Now, if you talk about y is equal to fx as a function, which is even function. So suppose you take fx is equal to x square, then f of minus x will be minus x square, which where minus will get absorbed. So f of minus x will be same as f of x. So if you see the graph of fx is equal to x square, this is this type of graph. And it is actually, if there is a 2 and you are getting 4 out of it, then at minus 2, you will also get 4. So both the outputs are same. Minus 2 is also 4, 2 is also 4. So this is symmetrical about y-axis. So this type of function is called even function, right? So you can write both type of functions. I hope you have understood now what
Yes,
both.
sir. Yeah, that's sir.
Okay. One more important point you can note that odd function always pass through origin. That is, if we have f of x, f of minus x is equal to minus f of x, and you put x is equal to 0 here. So f of minus 0 is minus f of 0. So f of minus 0 is f0 only, because minus 0 is 0, minus f of 0. So this will become 2 times f of 0 is equal to 0. So f of 0 is equal to 0 by 2, which is 0. So always odd function pass through origin, whereas even function may not pass through origin like this. This is an even function, but it is not passing through origin because it is mirror image about y-axis. So
Yeah.
being mirror image about y-axis means it can pass through origin, it may not pass through origin. But if odd function is there, it is compulsorily to pass through the origin. Then only it can be mirror image about origin.
So even function can pass through the.
Yeah, it may or may not pass through the origin.
Okay. Okay.
But
Yeah.
odd function has to pass through origin.
Okay. So yeah, done, sir.
Okay. Now you can share your,
Yeah. So I think you should stop screen sharing.
yeah, one second. Okay, so this slide is clear, that is x cube function is taken, and then x to the power 4 is taken. So x to the power 4 is similar to x square, x to the power 4, x to the power 6, x to the power 8. All these are upward opening parabolas type of function. Now, this is important. Can you spot the odd functions? And if there are even, you can spot the even also. So first one, the graph is given. What can you tell about it? Is it even? Is it odd? Yeah, it is none of them.
So I think A is even.
It is not mirror image about y-axis.
So A is not even. One is not even.
One is not even. It has to be mirror image about y-axis. Na? Because if
Okay.
you take, suppose, an input 1, the output
Yeah.
is coming something 1 like there. It seems so. And if you take -1, it is coming 0. So you're
Yes,
not
sir.
getting the same thing. Na? If you are just changing the sign of the input, that is minus x to x, the output is not same. Getting the point?
Yes, sir.
Okay. What about, is it odd?
Second one, I think, yeah, it's odd because it's
First
passing.
one. First one, is it odd?
No, first one is not odd.
So it is neither even nor odd.
Okay.
Okay, now we come to second one.
Second one, I think it's odd. Because it's passing through the
It
it's
has to pass to the origin
and
as
it's
well as it is the mirror image about the origin, then only. So let me share my screen 1 second.
okay.
So what is happening in second one is that this is actually the situation. As I remember, I forgot what it was. It was probably like this. Was it like this?
Yes, sir. Yeah.
Okay. So here, and the function was fx is equal to probably x cube, something minus 3x. What it was?
That's x cube minus 2x.
Minus 2, right?
Yeah.
So there are both ways of checking. You can check analytically also, whether it is odd or not. You can check geometrically also. How can you check analytically? You can just see that if you take f of minus x, so it will be minus x cube minus 2 into minus x. So minus will come outside here, and here it will become plus 2x. Minus you take common, so x cube minus 2x, and x cube minus 2x is fx. So this will be minus of fx. So this is clearly a odd function because f of minus x is coming out to be minus f of x. Now, if you talk about geometrically, whether geometrically it is an odd function or not. So you can see that this is the origin. And is this a mirror image? So this portion is in second quadrant. And this portion is fourth quadrant. This portion is second quadrant. They are mirror image like this, about this line. And if you see the other portion, so this portion in the first quadrant and this portion in the third quadrant, they are a mirror image about this line. So overall, the graph here and the graph here, like this, like
Mirror
this,
image.
are mirror image about origin, and of course passing through origin. So both way you can say that it is actually odd function.
Yeah.
So if you want to note, you can note this down, then you can share your.
Yeah, I noted it down, sir.
Okay. Yeah. Now
Uh,
let us move to
the
third
third
one.
one is not odd.
Okay. And what about even?
No, it's not even as well.
Okay, fine. Fourth one.
Fourth one is not even. It's not odd as well.
Yeah, correct.
Fifth one, I think it's odd.
Yeah, it's
It's
odd.
symmetrical and it's passing through the origin.
Yeah.
Sixth one, I think it is odd because it's
Mm,
symmetrical as well as uh, through origin.
Mirror image of origin.
Yeah,
Yeah, correct.
yeah, this one.
Would you like to do this?
No, sir, I think I can do it. It's fine.
Okay, fine. So now one more thing I want you to do today. Uh, I want to just check the syllabus which you have with the syllabus which was forwarded to me, and I have to make a plan and share with the team. So I will just check it. You keep on sharing your this with me. So I will just speak and you will. So you have first one second. Let me write also.
So this is the relationship ones. Here's the main topics.
Yeah, yeah, one second.
This is unit one.
One So unit one is your polynomial
Poly
function.
yeah,
Okay. So that has been forwarded to me. Let's see. Polynomial functions. Okay, I have this one. Then unit two is your rational
rational
functions. Okay, fine. That have been forwarded to me. Then unit three is your exponential
exponential
and
and
logarithmic function. That has been forwarded to me. Unit four is trigonometric functions.
yeah, don't.
And unit five is your characteristics of functions. Okay. And then you have
That
uh,
I think that's it, sir.
okay, and this is for you to do
Yeah,
culminating
these
at
are for me.
okay, this is so you have basically 5 minutes, right?
Yeah,
And we are currently doing unit one.
yes, sir.
And have we completed unit one?
No, we haven't. So we are in right now. In unit one, there are one, two, three,
Okay,
four,
okay,
five, six,
okay.
seven subunits. We've completed the first two today.
We have completed the first two subunits.
Yeah, see this one, we finished
Okay,
graphs.
okay. And there are total seven subunits.
Yeah.
Okay, so and more or less all the subunits will take the same time or different times.
Uh, so in this one, so this one I finished by myself.
Okay,
Introduction to that.
okay,
That's it, 2 hours. But I didn't
okay,
do it. It didn't need 2 hours. It just took like for 30 minutes for me.
okay, okay,
And this one it says 3 hours. You see, sir.
okay,
But it didn't. We only took I think maximum 60 minutes, like whole class.
okay,
And this one it says 2 hours.
okay. So actually, I have to make a plan for you, which has been just said to me.
Yeah.
So is it possible that you can share somehow the topics of the subunits, even if you don't share the hours?
Yeah,
Because
I can. The
hours are
subunits,
just
yes, I can.
subunits topic. Can you send
Yes, sir. Yeah,
of
I can.
each unit?
Of the other unit, no, I don't think I can send the other unit because yeah,
Okay, okay. The other unit you can't send.
because
Okay,
it is
that
locked.
that will get unlocked after you will do this.
After I finish this, all these, and then after I give the test. See, sir,
Okay, okay, okay.
this one.
Right, right, right. Okay, so I will make it accordingly. Fine. I just wanted to get an idea. Now let us start with the third.
Okay.
This.
Oh yeah, third. This
Okay.
is the third. Yeah, and the assignment I had the doubt earlier, right, sir? That one was the assignment for the second one. This one. So we've done that, the assignment. This one.
This one, yeah.
So we're done with this as well. Oh, so now we can start
No,
with.
I haven't got to what exactly are you saying?
No, sir,
Transform.
that was the assignment for the second subunit. So we're done with that.
Yeah, we have done with that.
Yeah.
Now we can start third subunit. Transformation of simple polynomial function. Okay. So transformation of simple. 1 second, slowly.
Yeah.
Just go to the previous slide. What you
Oh,
saw.
so that is not that. That is something.
Okay, fine. Let us move. Okay, we can look at the general form of the function and pull out of the key numbers we need to perform transformations. If a is less than 0, fx is reflected in the x-axis. Fine. Fx is stretched vertically from the x-axis by a factor of mod a. Okay. Mhm. If b is less than fx is reflected in the y-axis. Okay. Fine. Mhm. The horizontal axis of mod b. Fx is translated horizontally h units. Okay. Fx is translated vertically k units. Okay. So there are a lot of things in this, and it needs some time to explain it. It is not a small thing. Actually, it is transformation of graphs, and it is a major topic which has been they have given in one slide. So I will just explain it and by an example, but it will take some time. We won't be able to do it today
Okay.
because if I give you some hint, I won't go to detail of this right now, but I will give you some idea what we are going to do, which we will do in the next class. Like what happens if you don't do all of them together, later on we will do all of them together. Right now, if you don't do all of them together, what happens? Let's suppose if it is f of x minus 3. So this means if the function was like this, suppose it was a function like this. This was a function y is equal to f of x. Now it is asked to you to draw the graph of y is equal to f of x minus 3. So what you will do, suppose this is 1 where it is touching it. Here it is minus 3 where it is intersecting it. Now it is asked to draw the graph of y is equal to f of x minus 3. So you will shift it towards right by 3 units. That means the new graph would be like this. This will be the graph y is equal to f of x minus 3. And now the points where it is intersecting or touching them is, this is 0, this is 4. So it is not difficult, but it will take slight time. So this is the first example. This first example tells you that it has shifted by 3 units. Here also, it has shifted by 3 units. So the whole graph, you can just see that the whole graph here is shifted towards right. The graph has shifted towards right, from the left to the right. So by how many units? Shifted right by 3 units. Is it okay?
So is it it shifted right by 3 and in total it's 6, right?
No, only 3. All the
Oh,
points are
okay,
getting shifted.
so these are two different graphs, right?
These are two different graphs. One
Okay,
is
okay.
like I give you an example. If you have a graph, let us suppose y is equal to x square graph. It can be any graph. I'm giving you a simple example. Y is equal to x square graph. Now it is asked to you that you have to shift this graph by, you have to draw a graph of y is equal to x minus 3 whole square.
Okay.
So what you will do, you will shift this graph, which is y is equal to x square, by 3 units to the right. So if it is earlier touching the x-axis at origin, now it will touch it at 3. So
Okay.
similarly, in the previous graph, it was actually, let me highlight it by a different color. In the previous graph, it was actually intersecting at -3, and now it is intersecting at 0. Earlier it was touching at 1, now it is touching at 4. Is it okay?
Yeah.
So the graph has shifted 3 units to the right side. Got
Okay.
it?
Yeah.
So you can note this down. So this is thus the shifting towards right. If the graph is something like this, that this is y is equal to f of x plus 4. So can you tell me what will be the shifting?
-4 will be like towards the left
Yeah, so shift left
by 4 units.
by 4 units. So if you add something in the input, then by that unit, it will shift towards left. Or if you subtract something to the input, the graph will shift towards right by that unit.
Okay.
So this is one thing. Now, another thing is, this you have written or you are writing?
Oh, just a second.
Okay, just write it down. I hope you are following it, na, Sathya?
Yeah, yes, sir. We are done, sir. Yeah, you can.
Now, next thing is, there are 4 things basically. Actually, there are 8 things. Shift right, shift left. So we have done these 2 things. Then third is compress along x-axis, and there is a stretch along x-axis. Then there is shifting upward, and there is shifting downward. And there is this is compress along y-axis, and there is 8th thing, a stretch along y-axis. Finally,